Good morning, Year 12. Today I wanted to talk about Bernoulli random variables in a short video. And the reason why I've done this instead of going straight to binomial distributions is because we don't want to pass over it. It explicitly has a few points in our syllabus. Okay, Bernoulli distributions. So let's have a look and see about these points here and how we can work out what a Bernoulli distribution is in our syllabus. So firstly, a Bernoulli distribution is looking at two things, and we need to realize that we want to restrict the outcomes or restrict it to two outcomes. So that is, we're looking at things that we can restrict to two outcomes. Okay, and we'll call these outcomes either getting a success or getting a failure. So what that means is you might look at flipping a coin and you would say that head is a success, and therefore you're either going to get a success that you get a head or a failure that you don't get a head. It could be that you are... One second, I'll just pause it for something. Okay, so the other examples could be, like if you're trying to hit a board with a bow and arrow, then the arrow is going to either hit the target as a success or it's not going to hit the target as a failure. Okay, and what we'll call these Bernoulli distributions is we'll say X is Bernoulli distributed. Okay. Now you probably don't see that in your book with parameter p. Okay, so this is how we would normally say it. If we see this, we say X is distributed as a Bernoulli distribution with parameter p. Okay. We have seen other ones like normal distributions with continuous variables. However, because this is either a success or a failure, we would say that this is a discrete variable that we're actually going to assign either 0 or 1 as our results, as success is 1 and then failure will be denoted as 0. Okay, and the other thing is about a Bernoulli. As soon as we see Bernoulli, we want to recognize that there is only one trial. So you're only performing it once, and then we would say that is n is equal to 1. So just the technicalities of that, as opposed to a binomial distribution where you could have more than one trial. So it doesn't with more than one trial. Okay, and we therefore could say with only one trial, so it's Bernoulli. It's a Bernoulli distribution. Then the result of X is either one of the two things, is either 0 for failure or it's a 1, so for a success. And we would therefore say that X could be the set. It's either 0 or 1. That's a terrible. These are terrible. I normally write them really good, but whatever with that. So let's have a look and see. So for example, a few things with this. E.g., say you have 5 green, you've got 6 yellow, and 4 red marbles. Okay, if you want a yellow one, we could actually say, even though there's 3 things here, we could actually say it's a Bernoulli distribution. If we want a yellow, we're either going to get a yellow or we won't get a yellow. So from that, we can still say it's Bernoulli distributed, and the probability of success, which did I say earlier, is P. Okay, so the probability of success, which is P, is therefore going to be 6 of the 15. And the probability of failure, which is Q, or 1 minus P, Q, or 1 minus P. In your syllabus, it's only just talking about 1 minus P, and in your formula sheet, it only has 1 minus P, is therefore 1 minus 6 of 15, which is 9 of 15 for that. And we could go through, and we might even represent this, and I just want us to get used to this, as a, as our little table, and then we could therefore say that for our x, you either have 2 outcomes. You either have 0 for failure, or you have 1 for success, and we've seen these in year 11, but therefore the probability that x is equal to x, so the probability of our 0 getting our failure is 9 of 15, and the probability of that x is 1 is 6 of 15. Okay, so what that means, like what this is talking about, is if we did a graph of that, it would say that for my x, here's my x variable, and here's my y variable, the probability of x is 0, and 1, 0 was 9 of 15, so I could draw a whoops, that was what did. Let's just go dead. Okay, it's a one that we got up 9 to say of 15, and then the one that's the probability of 1 is, it's kind of crazy at the moment, is 6 of 15. Okay, so it will go up, 9 of 15, 6 of 15, that's totally not 2/3 of it, but that would be our histogram, and we could then draw our polygon on that to actually, represent, because, I mean, we're not going to use these for the topic, just say, but these I just want to bring up because the histogram will have a probability of 1, and this will also have a probability of 1, okay, i.e., this little part here and that little part there have the same area, and that triangle there and this triangle here have the same area, and that have the same area. So this had a probability of 1, as we know, and therefore this little red polygon also has a probability of 1. And I wanted to draw this picture because we've looked at these. We want to then see 2 things, okay? It's asking us to work out and understand 2 things in our syllabus. So I'll show you what I mean. Here's my thing. So hopefully we've now seen you can use a Bernoulli random variable as a model of 2 outcome situations and identify contexts of when we're going to use them. And now we want to work out our expected value and our variance. We want to look at our expected value and our variance of Bernoulli random variables. Okay, so let's have a look and see what we've got for that. Okay, so firstly, our mean. So let's have a look at our mean, which we know we've seen 2 formulas or 2 symbols for our mean. That is, we've seen our mu for population mean, or we've seen our x bar for our sample mean. Okay, so in your formula, sheet, I mean, it should be for sample and for population. However, this one here is a sample of just one trial. So, you know, it should be sample, but it's okay. So our mean, which we know is our expected value of x, okay, that is on our formula sheet. We can work this out. We know that the mean is the expected value, and what we know about that expected value is, hopefully you remember from previous studies, to work that out is you work out the sum of each of those, each of the, say, x values times by the probability of those, that x is those values. Okay, so that's how we worked out the mean from one of these. Okay, so that would be, if we could do it in a table, we could do it in a picture, but, you know, the sum of them, so x is, so 0, and that's times by the probability of that, which is the probability of failure, and then that's plus 1 times the probability of success. Okay, so that's what we would get for our mean, or in this case here, because it's 0 times probability of failure, which we know is 1 minus p or q, plus p1 times the probability of success. So it's just the probability of success, which is just p. Okay, in this case here, our mean for this graph is actually 6/15. So if I put this as from 0 to 1, our mean is 0.65. So, I mean, it's a bit of a kind of dodgy graph because 0 is not at the axis. But if I did, you know, draw this over it and put, here's my green, there's my 0, it should be, you know, going through that line, then the mean is at 0.6 about here. That's the middle of our graph. And that's what we should get for our mean. Our variance, which hopefully we know variance has two symbols that we'll use. Our variance is sigma squared, so the square root of the standard deviation. Okay, or we know that we could just use variance of x, and this is what they show on the formula sheet. So our variance of x, if we look at our formula sheet, can you please have a look? I hope you've got your formula sheet in front of you, but the variance of x is therefore found as the expected value of x squared, and then minus your mu, and actually it's minus mu squared. I'm just looking at my formula sheet here. Now, so this is what we've got, and we've looked at this previously. That is therefore the sum of, that's a terrible capital sigma, doing that one again. The sum of our x squared times by the, you know, probability that x is equal to x. Okay, I don't even need that brackets. And then that's minus your mu squared or x bar squared, whatever you want, which is p. So I'm just going to take away minus p squared from, instead of writing mu squared, because we know mu is p. So we can work this out. What's this part? The sum of all my x squared. So let's have a look. 0 squared times the probability of failure. Okay, plus 1 squared times the probability of success. Okay, and then minus p squared at the end. So this is my expected value of x squared minus p squared. That's nothing, 0 squared plus 1 squared. So 1 times by the probability of success, which is p. So that's the same as p minus p squared, which is the same as p by 1 minus p. Okay, I could just factorize p out of both of those. The reason why is because I said at the start that, let's find it there, that 1 minus p is equal to q. Now that's not currently on your formula sheet for bernoulli distributions. However, it becomes p q. And soon, when we look at binomials, we'll see this as np, and NPQ when we've got more than, when n is not just equal to 1. Okay, so hopefully that's what we've got. If we just check our syllabus info to see what I wanted to address this session to say is understanding what Bernoulli random variables are, and then understand and apply the formula for the mean of our Bernoulli variable, okay, the mean, which is x bar, this is just sample of 1, which is equal to p, and the variance, which is p by 1 minus p, of the Bernoulli distribution with parameter p and x defined as the number of successes. Okay. Understand the concept of Bernoulli trials and the concept of a binomial random variable. We're not up to those, as the number of successes in n independent Bernoulli trials. So what we've got is this, if I can remove it, is a Bernoulli trial because we only have one trial. There's either you're going to get a success or a fail. I'll leave this video here. I wanted to keep it short. Could you actually please look at the Maths in Focus exercise? I think the exercise is 1501. And could you please look at that 1501, just questions 5 to 12 before we move